Okay, good evening to my SV, Dr. Toiba, and also to all of my panels who will be viewing my slides. So I'm going to start off with my title, which is Study on the Effect of Sintering Temperature on the Properties of Dense Bioceramic Prepared from Eggshells. Okay, sorry. Okay, so the introduction. So what is bioceramic? So the bioceramic used in this project is calcium phosphate. So what is calcium phosphate? Calcium phosphate is the major component of bones in teeth. So there are a few types of calcium phosphate, which is hydroxyapatite, which is the pure calcium phosphate, and also beta TCP, alpha TCP, and GTCP. So these are the types of calcium phosphate. And also, why do we use natural resources to extract calcium phosphate? So because the calcium phosphates will be bioactive, biodegradable, and also bioinert. So, what are the natural resources that contain calcium phosphate? So, basically, we can see in bones, which is mammalian bones, fish bone, plants, and also biogenic, which is eggshells, seashells, and calcite material. Okay, so the major application of calcium phosphate basically is on bone replacement material, CAP coated implants, nucleic acid delivery, implantable drug delivery, and vaccine adjuvant. Okay, so these are the applications. So we move on to the problem statement. So the first problem statement is increase of waste eggshell. So basically there are many waste eggshells that are thrown away. So next is the existing implant material does not stimulate bone growth. So basically no proper bone growth in the existing plant. And next, a complex and expensive method is used to extract uh, calcium phosphate. Okay, so the objectives are to prepare and characterize calcium phosphate powder from waste eggshell using heat treatment, which is hydrothermal method is used to extract calcium phosphate from eggshells. So second is to study the effect of sintering temperature on the as prepared dense calcium phosphate via uniaxial pressing. Okay, so the third one is to characterize the physical, chemical, and mechanical properties of sintered dense calcium phosphate. Okay, so the methodology. So the heat treatment process can be seen on the graph, which is the sintering temperature used to sinter the dense calcium phosphate at different temperatures, ranging from 1050 Celsius to 1350 Celsius, with a soaking time of 2 hours and a heating and cooling rate of 5 Celsius per minute. So this is basically what the experiment is based on, which is to sinter dense calcium phosphate at different temperature to study the properties. So how to get the dense calcium phosphate? So this is the process flow of preparing the dense calcium phosphate and also after preparing dense calcium phosphate can be used for heat treatment. So these are process flow. So basically eggshells are washed and boiled in hot water. After that it is rinsed and then dried in oven for 24 hours and then crushed, and then the crushed eggshell are converted into calcium phosphate using hydrothermal method. And also the produced calcium phosphate is then compressed to produce dense calcium phosphate via uniaxial pressing. And so the dense calcium phosphate is sintered at different temperatures. So this is basically the methodology. So a bit explanation on the hydrothermal process to convert COA from eggshell to calcium phosphate and then prepare the dense body with different sintering temperature. So basically the first diagram shows the process to produce HA powder using hydrothermal method. So basically the calcium precursor which can be found in eggshell is combined with the phosphate precursor which can be found in ammonium phosphate. So both are mixed, pH adjusted, dried, crushed, and calcined at 400 Celsius until a HA body is produced. So the produced HA body is then converted into dense HA body via uniaxial pressing of HA powder, and then the dense body is produced. So the dense body is used to sinter at different temperatures to study the properties. Okay. So these are the basic characterization properties. So to characterize the calcium phosphate. So basically, SRD is used for phase analysis. Hardness test is used to measure the hardness of sintered dense calcium phosphate. FTIR is used for chemical analysis. SAM is used for microstructure observation. TGDT is used for thermal analysis, and also PSA is used to uh, measure of the particle size. Okay, these are past studies literature review did on uh, the processes. Okay, so the first reference is showing the direct conversion of eggshell to hydroxyapatite by sintering method. So basically, the parameters are the temperature used is between 1050 Celsius and 1350 Celsius, and the sintering was carried out for 2 hours with a heating rate of 5 Celsius per minute. So the results show a stable 800 Celsius revealing phase flow hydroxyapatite. Okay, the second reference is extracting hydroxyapatite and its precursor from natural resources. So the method used is thermal method. Okay, so the parameters are the temperature is between 800 till 1200 Celsius with a CAP ratio of 1.67. So the result from the CAP ratio of 1.6 and produce H sorry hydroxyapatite which is stable up to 1200 Celsius. So the third reference is calcium phosphate ceramic prepared from natural waste material. So this method uses hydrothermal method. So the parameters are this calcinate in furnace at 600 Celsius for 2 hours with a heating rate of 10 Celsius per minute. So the result shown is it produces pure and crystalline HA from waste eggshell. Okay, so these are the expected results. So the first diagram on the left shows the XRD pattern of HA powder after subjecting to heat treatment at 800 Celsius, revealing phase pure hydroxyapatite. So this is pure HA produced at 800 Celsius. Okay, so the below figure shows XRD pattern of HA samples sintered at different temperature ranging from 1050 Celsius to 1350 Celsius. So we can see that at different temperature, different type of calcium phosphate might be produced, such as HA, beta TCP, alpha TCP, or DTCP. Okay, so on the right is the FDI spectra of HA powder heat treated at 800 Celsius. So this is basically the composition of the calcium phosphate at 800 Celsius. Okay, so on the left side shows the SN image of HA sintered at different temperatures. So basically this is how the microstructure should look like in the calcium phosphate. Also on the right side shows the effect of sintering temperature on the relative density, viscous hardness, and fracture toughness of HA associated. So basically, this diagram should be same as the expected result. So all of these are the expected result for this project. Okay, so that is all from me. Thank you very much.